Hey, welcome back everybody. Long overdue, another video here from Blue Glow Electronics. Today we're going to show you how to bias the outputs on a Sansui 8080DB, but this also applies to the 9090DB and probably a few other models of the like. This is a model radio I got in a while back for an individual that just never got around to. Finally I found some time to help them out a little bit. Anyway, what I've done thus so far is I've basically recapped the whole output side of this thing. As you can see here, new caps on this driver output board, as well as the power supplies boards and input boards, etc. But once you get done changing a bunch of capacitors in the outputs and power supplies, you know, it would make a whole lot of sense to come along and bias this thing. So I thought I'd make a quick video on that. I will show you here, this is the it's the F2624 board, and let me show you something real quick. Okay, I got it powered off. This board is designed to, basically this thing unplugs right here, which I'm having a hard time doing with one hand, and this whole entire board here comes up and out like this. So, you know, the driver board here, you can see the four driver transistors there. Really easy to get to and recap this thing. I put some really good Nikon caps in this thing, and you can also disconnect this top thing so you can just get it out on the bench and work on it. So nice gold-plated pins on this thing, but we've got it put back in there, and there's actually a metal cover that goes over this thing. Looks something along this line that at the end of the day kind of comes along here from behind. And the little slot slides in right here, and it kind of locks this thing down so it can't move or go anywhere. But we did have to remove that to recap. And if you'll notice here at the top with that cover off, or actually with the cover on, it has 4 holes in it here. You could do it either way. We're going to be adjusting these potentiometers right here to adjust the bias on the output. I'm going to take you over to the video screen, show you just a reminder of what bias is, and then and what we're trying to achieve here. Alright, I'm going to drag you through a little bit of what I'll call slideware, i.e. PowerPoint. And let's take a look here. What is biasing? Biasing, as it relates to a solid state amplifier, is typically defined by doing 2 actions. Or 2 outcomes that you're trying to achieve. The first one is you'll take an action to make sure there is no DC voltage present on the outputs. In other words, if you put a voltmeter across the positive and negative speaker terminals, your voltmeter would show 0 volts. If you don't have that, with no input to your amplifier and with the volume turned to all the way down to minimum, then you got a problem, and I'll show you more about that here in a minute. And then the other thing you want to do is you want to set the proper idle current through the output transistors with no input. If you'll remember a little bit of transistor 101, transistors get turned on at a certain point when you're applying voltage to them, and prior to that point they are in a state called cutoff. In other words, there's not enough voltage there for the transistors to actually operate or turn on and work functionally. At the other end of the spectrum, once you've applied so much voltage that this transistor cannot draw any more current through it, but yet you continue turning up the voltage, you have reached an area which they call saturation. In other words, the transistor just can't do any more work than it's doing. And that's a bad state to be in as well. It causes things like clipping and distortion and whatnot. So ideally, what you're trying to find with an amplifier is a state in between cutoff and saturation that your audio signal can operate in, that's somewhat linear and not being cut off at the bottom end or cut off at the top end. Typically you do that by turning on the transistor just enough so that it's on, but yet not enough that you've reached anywhere near ends of saturation. In other words, you just barely want to turn the switch on enough that these things are sitting there turned on all the time with no signal into them. Okay, let's jump on to the next slide. But just keep in mind that barely turned on, that's kind of like, you know, let's say you had a light switch in your house that was variable and you could barely turn the lights on. You know, there's a point where you're turning it off, down, 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 and they just cut off. But if you start turning it on just a little bit, there's a part where it just starts to glow. That's the point we're looking for. Let's jump to the next slide here. So, if you don't have 0 volts on the output, it can result in two undesirable things. First is this clipping on your output. So right here, let's look at this line. That is 0 volts at the output transistors. In other words, if you'll remember, an audio signal is nothing more than a series of waveforms that will come along and be fed through this output transistors. In this case, we're representing it with a sine wave, but let's pretend this is 0 volts right here, this line. And let's pretend this dotted line up here is, let's just say 50 volts. If the power supply in your output amplifier, you know, if its maximum is plus 50 volts and minus 50 volts, then, you know, you have a potential here of a 100 volt signal, all the way positive to 50 volts positive to 50 volts negative. And what you want to do is set it so that with no signal in or at all, you know, you're kind of sitting at 0 volts on the output transistors. So if you accidentally turn this thing, let's just say to where we had maybe 10 volts right here, you got your bias set up to the point that you have 10 volts on your output with no input. Well, then when your signal comes along and it starts amplifying it, and let's say it's a 50 volt signal, well, you're already sitting at 10 volts. You try to add 50 to that, it starts going up. It gets here to 40 volts on your signal, and bam, you're hitting against this 50 volt maximum power supply limit you have. And all the other 10 volts of your signal are getting clipped off at that point. And then it's able to swing back down. It's able to go back below 0, and you're able to get all the way back down here. And so you kind of hear half your signal, the other half's getting it clipped off. Let's say you had your bias level too low. In other words, it's not at 0 volts, it's at minus 10 volts. Same scenario. Your audio signal comes along, starts to get amplified. The positive peaks of it sound great. You get to your negative peaks here, wham, you're going to slam into this 50 volt point, because the middle of your sine wave is right here now, not in the middle where it should be. So ideally what you're trying to do is balance the positive peaks of your signal and the negative peaks of your signal so that they're kind of sitting right here in the middle on your amplifier output. And you also want to make sure you have the maximum amount of positive swing and negative swing that you could have for your output. You know, the more voltage you have here, if you remember the whole equation for power on the output, it's kind of this V squared over R. So you kind of take the peak voltage, square it, divided it by the output resistance, which is typically 8 ohms or so. So the more swing you have here, the more power this amplifier can produce. So that's why you want to make sure you have, one of the reasons you want to have 0 volts on your output. Otherwise, you're robbing yourself on one side or the other of the signal. Or what you'll end up doing is, to get rid of the clipping, you'll turn your volume down so that your amplifier is only amplifying 40 volts positive and 40 volts negative. If you go any further, you start hearing a lot of distortion. So you turn your volume knob back a little bit to the left, and you're like, okay, it sounds good here. But the reality is you've robbed yourself of 10 volts, you know, 10 times 10, square that, that's 100 volts, right? And then divide that by 8. You probably lost about 12 watts of power or so in not having your amplifier biased properly. All right. Number 2, what does it do if you don't have your amplifier biased properly? It causes damage to your speakers. Now let's take a look at what makes up a speaker. So first off, you got this, I'm going to point right here to this big V. This is nothing more than the cone in your speaker. And that big piece of area right there, and typically you got a dust cap that goes over it here. That big cone is what goes back and forth. You can see it right here in this picture too. The cone, that's what moves back and forth, and because it's solid, it moves air, and because you're moving air, you're changing sound pressures. Those sound pressures levels come to your eardrum and move your little eardrum, and that's how you hear music. So first off, this cone here has to be able to move in and out of this speaker freely, very, very freely, okay? Next up, you've kind of got this little area here called the surround on both sides, and what that does is it just, and typically here it's foam or cloth or something, you'll see the little rounded edge. What that does is it keeps the the speaker cone in place, but yet gives it the flexibility of moving in and out some, okay? That's why they're typically made of some flexible, bendable material. Then you have this thing down here on the back end called a spider. It typically goes here between the chassis and the cone, and it's really nothing more than to keep dust out. It keeps dust from coming up in the back of your speaker. This orange, yellow thing I'm pointing to down here, that's the spider. It keeps dust from getting in here and getting down into your voice coil. So on the bottom of the cone here, right, on both sides, it connects to this little cardboard piece that is wrapped in wire, and you can see the cross section here of the wire, or you can see here what it looks like. It's just coils of wire around a paper cone, a cardboard cone, that is ultimately glued to this cone up here. And as you hook your wires, your speaker wires, up to this voice coil, it's nothing more than a magnet. And as it moves, the current comes through into the voice coil, it basically moves up and down, in and out, matching your signal, your audio, and moves the cone here to match. So pretty simple concept. You also have a magnet here that is designed to keep the coil centered, in other words, pulled back to kind of its zero spot. It's so almost the zero bias spot on the speaker you could think of. Otherwise, as the music plays and goes forward and comes back down, you don't want the coil either bottoming out or leaving outside of its range of movement here on the chassis. And then you have this little section here in the middle. It's typically nice and shiny metal that is called the center pole, that kind of it's part of the magnet setup. So anyway, here's what happens. If you don't have zero bias, then this voice coil here gets engaged at 10 volts. Let's pretend back from that other one, or minus 10 volts. So either with no music playing whatsoever, your speaker is boom, popped out maybe a quarter of an inch or an eighth of an inch all the time. And then, or the same way, if it was negative DC applied to it, boom, it's pulled back down here in towards the magnet, maybe a quarter of an inch or something all the time with no signal in. So once you start playing music, guess what? Much like the clipping that you had in the amplifier, you'll also end up with clipping on your speaker. In other words, bam, when you apply 40 volts to it, it bottoms out and your speaker can't make the full range of movement it needs to. Or the 40 volts positive, bam, you're going to hit up here on this side. It just can't go the range it needs to. And ultimately, that's a bad thing, because then your speaker's not making good noise. Your amplifier's got distortion in it. It just ends up being a horrible scenario. But even worse than that, when you apply voltage to a coil constantly, right, guess what you get? This coil is made up of nothing but wire. When you take a long, say 1,000 feet of wire or 600 feet of wire or something, really fine wire, wrap it around this little coil, guess what you end up with? Wire has resistance, right? So you're applying voltage, you've got resistance. What does that produce? It produces heat. Remember, that's the way resistors dissipate power, is through heat. And so there's no movement here to help cool the coil down. It's just sitting there producing heat, and this is what you end up with right here on the right hand side. The coil produces heat, which ultimately breaks down the lacquer or veneer insulation around the wire itself, and you end up with your voice coil ultimately will either get to the point that, because the insulation is breaking down on it, it starts bubbling and popping. It's not nice and smooth like on this good voice coil here. All of a sudden it can't slide up and down inside of this slot easily, and so you hear this sounds like sandpaper inside your speaker, and it's because the insulation's broken down and starting to kind of interfere with the movement of the speaker. And if you let that process keep going, the insulation breaks down to the point these wires start touching each other. All of a sudden, you don't have this high resistance. You end up with a much lower resistance, and all of a sudden you end up with a short. And then this is what happened. It really breaks down and starts melting, and your whole entire speaker locks up. Now, bias being off a little bit here or there probably won't cause this scenario, but it will cause the previous scenarios I talked about. Your insulation might start breaking down, your speaker doesn't move as freely, and or you're maxing out on your movement of your speaker here, and it's just causing really bad speaker movement, and like I say, maxing out on each end, ultimately robbing you of your sound. And you've also got the distortion back in the amplifier from the clipping. It's just a bad thing. So what have we got to do? We've got to get rid of this voltage on the output, and we got to make sure this amplifier is sitting there turned on just at its right point right here at 0 volts, turned on just enough to kind of have these things sitting there idling, waiting for the 50 volt swing positive, waiting for the 50 volt swing negative, so that it can amplify all of your sound and send it to your speakers. And then ultimately this voice coil can move freely as far as it can move forward and as far as it can move backwards with that 50 volts, and there'd be no distortion caused by that. Let's jump back over to the amplifier oh nope, before we do that, one more thing. Okay, now that you know a little bit about what biasing actually is, how do we go about it? It's pretty easy stuff. It's one of those things. I've been in places before where I hear audiophiles or whatnot talking about biasing like it's this mythical creature that only someone worthy could do, or maybe the guy behind the green curtain or something. But it's not all that bad, guys, gals. We can do this stuff. So first thing you need to do, download the service manual. Just so you know, there is an 8080DB/9090DB service manual. It's a combined manual, and it addresses both of the units. There is also a 8080/9090 manual, and while the procedures are pretty much the same, they're slightly different, and I will show you the difference. So this video will kind of cover how to do all 4 of those units. All right, there's 2 different kinds of measurements you're going to do, or basically 2 things you're going to make sure conditions are set the way you want them. The first one's over here, number 1. So I blocked out this little section here. They accidentally left that section in the 9090 and 8080DB manual, but it applies to the 8080 and 9090 and not the DB versions. But what the heck, I marked it out. So number 1, you're going to use a digital multimeter, otherwise known here as a voltmeter, and in parallel with your speaker terminals, you are going to measure the DC voltage on the output with no input, with the volume turned all the way down. So pretty simple measurement. I would recommend having this thing hooked up to an 8-ohm dummy load, preferably a non-reactive dummy load, like some resistors that are non-inductive. And at worst case, you can use a speaker if you have to. And rating number 2 over here is on that F2624 driver output board. There are 4 variable potentiometers right here, VR1, VR2. You can see them here as I circle VR1, VR2, VR3, VR4. And there are 4 fuses on this board. What's weird though, they're not actually up here on this board. They are on the board down below it. So this is kind of a top-down view. If you remember that little slot where the metal thing slid in. 1, 2, 3, 4. And these fuses are down here on the kind of the power supply board below. And there's 4 fuses you're going to be concerned with. There's 5 actually on here, but the ones you're going to be concerned with here, you'll see, are F04 and F05. So let's jump to this. But one thing I do want to make note of here, I want you to see, when you're measuring here, you're actually going to remove the fuse, and you're going to take your digital multimeter and you're going to get it into current mode, or ampere or milliamp reading mode, which means you will probably have to move your little connection on the positive side of your multimeter leads from the voltage meter section over to the ammeter section on the meter, and we'll look at that more. So this reading's in parallel, this reading is actually in series. You're actually, in this case, the current flows from these driver transistors through these fuses over here to the back where this big heat sink's at, where the 4 output transistors are mounted. And basically you're measuring the amount of idle current flowing through them to these output transistors right here. Okay? All right, now that you know kind of what to adjust and how you're going to hook up your meter and whatnot, you're going to want to know, how do I actually do what do I adjust the settings to be? So here's a few key things you got to do. First, turn your unit on, leave it on for 5 minutes or more. You want this thing to thermally have stabilized. In other words, all the components in it warmed up, heated up, all the voltages stabilized, all the current stabilized, etc. You want this thing to be on for a few minutes and just kind of sitting there idle. Ensure you have some type of dummy load connected to the output. Like I said, preferably some type of resistor, non-inductive resistor setup, or potentially, just a speaker. Put your input all the way to, in other words, turn the volume knob all the way to the left, and don't have an input signal either. So if you've got a function generator plugged up to this thing, or maybe your iPod or your phone or something, turn those things off. No input signal. So it's 4 easy steps. 2 you're going to do on number 1, which was way over here like this on the speaker terminals, and 2 of them you're going to do over here on this board. So first, what you're going to do, DC 0 volts on the left hand channel. You're going to digital multimeter. You're going to measure what? The speaker output terminals on the left hand channel. You are going to adjust VR1, variable resistor 01 on this driver board for 0 volts on the output. It's going to give you a little wiggle room here. It says plus or minus 10 millivolts. Try to get the thing as close as you can to 0. You really don't want any output, but it is hard. Sometimes I'll end up with 0.0002 or something like that, 2 millivolts. Sometimes that's hard to adjust and get it all the way down to 0 because these potentiometers are just not that accurate, in all honesty. So get it as close to 0 as humanly possible. It does tell you here, hey, if you're using an older analog meter or something with multiple ranges that you have to adjust, you may have to adjust those properly to get you on down into the millivolt range you're reading. And if your meter pegs the wrong way, we'll then change the leads around if you've got an older analog meter and get it going the other direction. So you're going to measure and adjust VR1. And if you look here, VR1 is right here. You're going to adjust that, reading these left-hand terminals. Same thing here. You're going to adjust VR2 on the right-hand channel. So right here, VR2, measuring these right-hand speaker terminals over here. Oh yeah, by the way, ignore this section right here on this for this amplifier. And then what are you going to do? You're going to do the 2 number 2s. Guess what? Left channel and right channel. Left channel. You're going to put your meter in there, but you're going to move the lead over and turn it into an ammeter. You're going to measure across F04, the fuse 04. You're going to pull that fuse out, and you're going to put your multimeter in series with that fuse. So basically, instead of flowing through the fuse, you're now flowing through your ammeter. You are going to adjust for 30 milliamps of current, plus or minus 1 milliamp. And that applies to the 8080DB and the 9090DB. 30 milliamps of idle current flowing to those transistors. What you're doing, you're feeding just enough to keep them turned on at all points in time. Like we talked about earlier. There again, you might have to step your meter down. And you will actually adjust VR04 here. Is that what it? Nope, I'm sorry. For fuse 04, we adjust VR03. Boy, they could have made that simpler. So you're adjusting VR03 over here, for fuse 04 over here, and then you're going to adjust VR04 here, right here, for fuse 05, which would be VR4 right here, and you're going to measure the current flowing through this fuse 5. So it's really just these 2 fuses. Don't pull them out at both at the same time. Do one at a time. Get them set to the setting it's telling us here, 30 milliamps, regardless if it's an 8080 dB or a 9090 dB. Hopefully you followed that along. If not, I'm going to show you how to actually do it here in a minute. One thing I will tell you, Settings are slightly different here for the 8080 and 9090. In other words, the non-DB version. Let me show you what is different. If you'll notice right here, everything's pretty much the same except for you're messing with fuse 7 and fuse 8 instead of fuse 4 and fuse 5. And these little potentiometers are in different order now. If you'll notice earlier, they went 3, 1, 2, 4, and now they go 4, 2, 1, 3. So make sure you're following along up here with the right things. But the big difference here, remember that little part I X'd out earlier in the section, this part here? This actually applies in the 8080 and 9090. So it'll tell you here in the adjust, there are 2 model numbers. Regarding the model number, please refer to the note on page 1. So here's what page 1 says. Page 1 basically tells you nothing more than the model A is the 9090 and the model B is the 8080. The 9090 is a higher output unit, and they recommend biasing with a little more current to turn it on. It's using slightly different transistors in the output. And so you'll notice right here, it'll tell you on the A, you put 50 milliamps. If you had a 9090 model, and if you had a B model, which was the 8080, you would put 30 milliamps. And I notice here's another mistake. Look at this. It says 50 millivolts, even though it's telling you to measure current. And it even tells you plus or minus 1 amp. So that should have been an A right there. And the Model B, 30 milliamps. But in the case of the one we're working on, the DB model, you're going to do both of them at 30 milliamps right here. Let's jump over to the actual unit, and I'll show you a few things about it and show you what we're doing here. Okay, back over here to the amplifier. One thing I would recommend you do, double check these things, because sometimes the pictures in service manuals are not always accurate. I'd go with what's on the board. This one has VR3, VR1, what is that? VR2, VR4. Just make sure that that's the same as the picture. If not, I'd probably go with what's here instead of the picture. If you notice, behind this driver board is the great big heat sink mounted to the back panel. And if you'll notice down in there, there are 2 pairs, one for left channel of push-pull transistors and another pair of push-pull transistors down here for the right-hand circuit. And what you're actually doing when you're adjusting this bias, the idle current settings, you're making sure that these little driver transistors right here, flowing current out to these output transistors right here. You know, we're setting them at 30 milliamps. In other words, we're just barely turning these transistors on. But you want them on at all times, because you don't want to have to go through what's called a transitional state with your transistors as the signal comes through it, actually turning it all on and then, you know, amplifying and turning it off and back on. You want these things always on, basically. All right, so back over here, one thing I want to point out to you, these are the 3 multimeters I use the most around here on my bench. We've got some other ones, some bigger, nice, like up here is a fluke meter that we use a lot, a bench meter. But if you'll notice, all of them typically have a voltage range, and then you will have some type of current range over here, milliamps or amps, right? Well, to use this range over here, you actually have to take the little lead out of the, boy, that thing's hard to get out. You have to take it out of the multimeter and move it over here. So this is the 40 milliamp range. You'd move it here if you're going to use a milliamp. This is a 10 amp range if you were going to use this this amp setting right here. So you had to move your leads as you're moving from measuring voltage to amp. Same here. This is a voltage. Notice right here. And these things, this 8060s are legends. Been around forever and great units. But if you'll notice, if you're going to measure current, what do you got to do? You got to move it over here to the little ammeter section, and you would have to change your settings here. Same thing here on this little EX Tech. You know, you got your voltage settings, you got your micro and milliamp settings over here, and that's what you do. You move your settings, and you'll notice it'll tell you over here to kind of move that thing over. Anyway, I'll use the Fluke 179 today to do these measurements with, because it's got big letters on it, really easy to see. And let's get this thing set up. I will tell you, I'm going to cheat a little bit. So as part of my bench setup. So what you would typically do is kind of spin this thing around here, and where your speaker terminal wires go in at right here, you would also kind of insert your multimeter in there with it, or you may be able to come on this side and figure out where the terminals are, and you'll be able to clip your little leads onto like that point and that point right there. Well, because my bench feeds up through this, up into this little BNC breakout thing that I've got. One of the things I do, if you notice this blue connection here, feeds out of pin number BNC connector number 2. Well, that blue line feeds up and over here, and if you'll notice the blue connector on it here, what does it feed into? It feeds into my Fluke dual display multimeter. So I'll be able to read this meter and measure my output and not actually have to hook you know, plug in here into the back like the picture says. But you could easily do that. You could take your little leads here, just like this, and probably have some type of clip ends or something on them, and you could come down here like this and clip on the inside here. It's a little bit dark for you to see that right there, but there you go. You can see the back side of the speaker terminals here, and you could come down in here and actually clip into that right there and be clipped on. And you just do the same with the positive side and measure that way. It's a good thing about having a nice bench set up, because this thing's ready to measure, but I don't have the thing on right now. So let's get the amp turned on, warmed up, and we'll come back and measure the two right and left voltages. Okay, I decided that using my meter up there would be cheating, and it's hard for me to move back and forth between adjusting and showing you the meter way up on my bench. So thought I'd show you here. I've got these two connections going right now to the right hand speaker lead, and I've been adjusting VR2 over here. And if you'll notice how this thing does, it bounces around a little bit way down at the milliamp range, and that's kind of normal for these things. In other words, you're trying to get it as close to 0 as you can, but it's going to bounce 5 or so milliamps back and forth. I'm sorry, millivolts. But what you don't want is it kind of bouncing up near that 20 or 30. You want it kind of hovering around 0, and so that's kind of where I got this thing. It's hovering from -5 to plus 1, 2, 3. Etc. And boy, is that thing sensitive. I just used a little screwdriver here. Get into VR2 here, and as you turn that thing just the slightest little bit right there, I'll show you here. I'll turn it just a hair. All of a sudden, I'm bouncing up around -17, -15, -10, and not going to the positive side any. So I'll turn it back just a hair here and get in the slot. Okay, there we go. I'm starting to bounce, but still I'm all on the positive side here. I want to get that thing bouncing right around 0, with a little bit above and a little bit below. Let's see what I end up with. No, that's a little too far. That's a little too far. These things are touchy. Okay, that's good right there. I'm back down into the right around the 0 range right here, if that makes sense. And then we'll move the leads over here. I'll show you to the other speaker lead. Same thing, I've got it adjusted pretty good. Notice how it's bouncing right around 0 right here on these two leads. And for that one, I've been adjusting VR1 right here on this side to get it kind of where I wanted it at. And that's pretty good right there. Like I say, you're not going to get these things to hover spot on 0. Some amplifiers are better at being steady here, but you're talking about idle current, so a lot of things can be affecting that. You've got probably picking up noise here in this line feeding into the aux input. These lights are probably picking up a little bit, so you're never going to get completely kind of idle there. A little bit of current flowing back and forth. So let's jump into the voltage measurement. The current measurements. All right, let me show you what I've got going on here. Got my meter over here. I put it on milliamps. I plugged into the 400 milliamp section here with this. I pushed the yellow button to get it on DC milliamps. And if you'll notice, I'm hovering right now up around 21 millivolts DC. Okay. Let me get the bottom of this thing out. Okay, so you can see now 20 millivolts. All right, so this is where the manual is wrong yet again. Sansui, get your act together. Anyway, let me show you. So if you'll notice down here what I've got going on, I've got these two leads basically connecting across where the fuse is at. In other words, the current's flowing instead of through that fuse out through one of the leads of this multimeter, through my ammeter over here, in through the other one. And let me show you what I'm seeing. See, this is VR4 right here that I'm inserted into. Watch this when I turn it a little bit. What happened? We went from 21 millivolts to 28. Watch what happens when I turn it the other way. 30, 40, and go too far, 15, 20. Anyway, I got to adjust it. I just wanted you to see VR4 was actually adjusting this thing, and I'm going to get it to 30 milliamps here in a second when I drop the camera. Any rate, if you look at the manual, it tells you VR3 adjust when you're connected across fuse 04. So VR4 adjusts when you're across fuse 04. VR3 adjusts when you're across fuse 05 down here. So yet again, the manual has a mistake in it. The spirit of it's right, the gist of it, but yet a technicality. So sometimes you got to pay attention for these things, and it took me a minute because I'm sitting over here turning VR3 and my milliamp range is not adjusting at all, and I'm going, something seems really odd there. But then after I I said, well, let me try this one over here, and I adjusted it, and all of a sudden I started getting something out of my meter. Let me get that thing set on 30, and you notice it still bounces around a little bit. So what you want to kind of do is get it hovering right around 30. Right now I'm hovering around, high 27 or so. Okay, if you notice I'm hovering around the high 25, 29.678. I'm going to leave it right there, as close as I can get it to 30, because as soon as I start adjusting this thing up near 30, it bounces over to 31 or so. And I would rather be slightly less. One, less current on these transistors, lasts longer. Two, remember that little bias offset thing we had earlier? I'd rather be slightly below this value than above this value, because I'm less likely to push the limits on anything. Let's get this fuse back in. Oh yeah, by the way, there's the fuse I took out, and you can see right down in here where these red and black leads go. By the way, these really long alligator clips like that are amazing. I use them all the time. Okay, we got that fuse back in, the other one back in on the other side. By the way, please, when changing all this, swapping out the fuse, changing these leads, please power the unit off in between. But look at this. This thing's sitting here at 51 milliamps of current. At idle, that's not good. That's way overdriving these transistors at idle. So what are we going to do? Check it out. Which one am I adjusting? The one over here, VR3. And we're going to get it down to, let's see if we can get it down here. Not the best left-handed because I'm holding the camera in the right hand. Okay, I'm going to leave it right there. I'm at the same place, hovering right below the 30, and I'm just going to leave it. I think it's great. Alright, I hope you've learned something today. That is how you bias the output of a Sansui 8080, 8080DB, 9090, or 9090DB. Notice there's few errors in the manual, as well as slight differences in the manual between the 8080, between the DB and the non-DB versions. Just to let you know on this amp what all else I've done to it. Done pretty much a full recap on this thing. Put blue LEDs all in here, new vellum in behind that. I'm about to light these up. The individual asked me any way to get these meters here kind of glowing blue, and we're going to play around with that a little bit. I ordered some blue little grain of wheat bulbs, so I can get it glowing blue that way. If not, I could strap in some of these blue LEDs in behind it or something, but these things were never really designed to be blue here. Of course, the rest of it kind of was. So, alright, we're going to call it a wrap. Sorry I've been not so frequent in my videos lately. Just had a lot going on, trying to get some of the building remodeled down there, and had a lot going on with my record label here as well the last little bit. All hobbies, which I barely have time for, but we try to fit them in. Get this one off the bench. One more receiver that someone had sent back to me they were having an issue with that I'd restored a year or two back. If I get it fixed, I've got an amplifier I've got to get something straightened out on, and then at that point hopefully I'm off to building some stuff instead of repairing some stuff. That should be fun. Thanks again, everybody. I know it's not a short video. I said it would be, but that's my game. Thanks.